Hey guys, my name is Ryan. I'm the Chief BD Officer for a blockchain project called Moac. So Moac is a public blockchain platform, and we started the Moac project initially with a goal to solve the very famous trilemma problem, which security, scalability, and decentralization. It's very easy to have two of them, but it's very hard to have three of them. So starting from there, we have come a long way. So for the Moac project, we started around January 2017. So till today, it's been 2 years. We launched the mainnet April last year. So it's the mainnet has been up and running for a while as well. And in Moac, we have implemented roughly around three features. So the first one is a hybrid consensus. So we are flexible in terms of consensus protocol, and we work with POW, POS, DPoS, or some custom consensus protocol. We have implemented sharding, and we are ready to implement the cross-chain. So it's still under development at this point, but we're aiming to release the cross-chain feature later this year. So I think let's we don't have a lot of time, so let's just, dive into the technology. So when we first tap into the problem, we think about what kind of what's the thing that's make the Ethereum blockchain have a TPS that's not very good, right? So when we are looking at all the transactions on Ethereum, we think there are two type of different transactions. So one type of transaction, we call it balance transfer, which means how you transfer money from one wallet to the other. And the second type of transaction, we call it smart contract processing, which is for example, in a game like CryptoKitty, when you generate a new kitties, what's the color of the tail of the kitty? You need some kind of calculation to calculate it out. So this kind of smart contract processing is another type of transaction on Ethereum. But for these two type of transactions, the balance transfer, we think it's a higher priority compared to most of the smart contract processing. But at the same time, the smart contract processing, it takes much more computation power. It burns much more gas to deploy versus a very straightforward balance transfer. So that's how we come up with this kind of two-layered architecture. So on the bottom layer, we handle all the balance transfer type of transactions, and for anything that's related to smart contract processing, we keep it to the upper layer. So with this kind of two-layered architecture, we are able to handle the balance transfer in the lower layer, which we run a POW on, and for all the computation intensive smart contract processing, we keep it on the upper layer. And at the same time, on upper layer, we have implemented sharding. So we group the nodes on the upper layer into different shards, and we group each of the shards kind of like a subchain type of solution, and we call it a macro chain. So this is what the architecture overview looks like. So when a transaction comes in, we say, hey, whether it's a balance transfer or it's a smart contract. So if it's a balance transfer, then it goes to the right, and this transaction is relayed to the bottom layer, where we do a regular, proof of work validation, and we handle the balance transfer on the global POW layer. So on the bottom layer, we call that mother chain. And if it's a smart contract processing, it goes up to the upper layer, where we have Ethereum virtual machine. So we make it Ethereum compatible. We are just using the Ethereum virtual machine at this point, and we handle it on the upper layer. So on the upper layer, we call each of the shard as a macro chain. Since we are able to group different upper layer nodes into different shards, now we are able to handle different type of smart contract processing in parallel. So with that, we actually launched a feature called OC Square, which stands for one clicked, one chain. So that means for each of the macro chain, since they have their own consensus protocol, they have their own configurations, we can treat each of the macro chain as a standalone blockchain, and we can use it as a standalone blockchain. And how to create a macro chain. So basically, when you have your smart contract ready, you can just define, okay, so for this macro chain, we want to have, for example, we want to have 1,000 nodes in the macro chain, and we want to have this kind of node, maybe nodes that's reach to certain bandwidth requirement or certain storage requirement. Then we select, okay, what kind of consensus protocol do we want to take for this macro chain? And this is really based on what is this macro chain used for, right? So for example, if this macro chain is used for storage, we might choose IPFS, or if we have some other purpose, we might choose POS, right? So we have provided a few of the default consensus protocol, and if anyone want to come up with their custom consensus protocol, we have the API to hook it up. So we want to make it in a plug and play type of style to implement the consensus protocol. And then there are a few other parameters you need to set up. For example, the flush frequency. That means when you want to synchronize the data from the macro chain back to the mother chain, because remember, only the mother chain is in the global consensus. So the macro chain is only a local consensus between the nodes that's made up this network. So you need to flush a hash of the state into the bottom layer, and this hash is basically a record for this macro chain for certain things to come into the finality. So that's flush frequency. And we can also set up the other parameters like how often do you generate each of the block, as well as what do you think is the ideal size for each of the block. You can set up all these parameters, hit the button, and you can deploy a new macro chain start from there. So the other thing about macro chain is that right now we have developed the inter macro chain functionality. Means that one macro chain can be used to serve the other macro chains. So for example, I'm building a dApp, but I need some storage capacity for this dApp. So in that case, I don't need to implement a IPFS from scratch. If there is another macro chain on top of the network that's already running IPFS, I can use their service to store my data, right? So we have already enabled this kind of macro chain interconnection, and by leveraging this, we can potentially develop a macro chain as a service type of model, so that different macro chains can service each other. And the other innovation that we come up with this kind of architecture is on the mining part, we also set up the mining as 2 layers of mining. So on the bottom level, since it's running POW, so it's very traditional style POW type of mining, just like how we mine Bitcoin or Ethereum. But on the upper layer, on the macro chain layer, we have a different type of mining. So since it's a developer who handles and who manage and controls the macro chain, we want the developers to come up with a reward program for the miners. So if the miners are contributing to the computation power of the upper layer, which is the community are doing mining for the upper layer, the developers are responsible to pay for their service, to pay for the mining. So we designed this way on purpose because of we think that for most of the dApps as of today, it's not very friendly for the general public, because if we ask each of the users to pay for each of the transaction, that's not beneficial for the actual adoption all these users. They need to get Ether first, or they need to get, you know, some kind of coins first in order to use the app, right? So we want to make it in a way that, you know, it's free for the users. The users are free to just download and just to use it immediately, and all this transaction fee and all this, you know, computation related costs should be covered by the developers. It's just like when you offer a service in a traditional architecture, you rent the AWS, so you got to pay for the service of the AWS. It's kind of a similar idea. So with that, we are able to achieve a lower layer of TPS around 2000. And on the upper layer, on the macro chain level, we are able to achieve somewhere around 5000 TPS. And since the upper layer, each of the message are relayed through the lower layer, the bottleneck of the TPS here is really based on the bandwidth. So the more bandwidth, the more TPS we can achieve on the upper layer. On the gas fee side, since we have eliminated the smart contract processing from the lower layer, so we can offer a much lower gas fee compared to Ethereum. And on the upper layer, as I mentioned before, you know, it's free for the users, but the developers are able, they are responsible for to pay back their miners. So that's about it. I think, you know, with this, you should have a basic overview about, you know, what we do at Moac. And so if any collaborations or any questions, feel free to propose here. Thank you.
How many people are using the platform now?
So currently we have around 40 DEX partners. We call that ecosystem partners. And currently we have a registered wallet somewhere around a little bit over 100,000. So I think, you know, transaction per block wise is somewhere around, you know, like tens of hundreds of transaction per block. So that's around the, you know, user activity on top of this chain.
Okay, cool.
Yeah.
Cool.
Yeah.
Have you looked into like how many portion are smart contract transactions and how many are real balance transactions on Ethereum?
No, I haven't looked into it.
Okay.
Right.
So and another question was like you said that you fall in between the three: security, scalability, and
Right.
I'm just not pretty sure like how secure you guys are.
Oh, okay. So really quick, in the macro chain, right? Each of the nodes in the macro chain, they don't directly talk to each other. So I'm a node in this macro chain. I have no idea who are the other nodes that's made up this macro chain, right? So currently what we do is we broadcast through the bottom P2P layer, right? And if a node that belongs to the same shard pick it up, then, you know, it can process information. So that's how we can guarantee the security using the bottom layer as a kind of a security guarantee for the upper layer security. Yeah. Thank you.